Hello class, today what we're going to talk about are the graphs of logarithmic functions. So a logarithmic function, as we saw in the previous video, what this is the inverse of an exponential function. So here if you look, the exponential function is in blue, the logarithmic function is in red. So here's an exponential growth function, and for this the base is greater than 1. And the inverse, this logarithmic function, again, the base is greater than 1. And you see how this is inverse of the exponential function. It's a reflection over the line y equals x. And instead of going to the point 0, 1, it goes to the point 1, 0, because the x's and y values get switched. All right. Here we have an exponential decay function because our base is between 0 and 1. Remember, your base will always be positive. And the inverse of that is the logarithmic function. Again, we have this inverse, it's a reflection over the line y equals x, and the x's and y's are switched. So it goes to 0.01, this one goes to 0.10. Now, from this, if you'll notice, in the exponential functions, the function has an asymptote at the x-axis. It has a horizontal asymptote. If you remember an asymptote, this is a line that the graph of the equation will get very, very close to, but will never actually touch. All right, it's a lot like that electric fence to keep your cows in your field. They'll get really close to it, but they're not going to touch that sucker. All right. Same thing with asymptotes. With an exponential function, you have a horizontal asymptote. With the logarithmic function, you have a vertical asymptote at the y-axis. All right. Doesn't matter which way this logarithmic function is going, you will have a vertical asymptote at the y-axis. Also, if you'll notice on the logarithmic functions, where you had the exponential functions had a domain of all real numbers, the logarithmic functions have a range of all real numbers. The exponential functions had a range of y greater than or equal to 0. Sorry, not equal to, just y is greater than 0. With the logarithmic functions, the domain is x greater than 0. All right. So again, x's and y's are switched. The asymptote gets switched from the x-axis to the y-axis, and so there it is. The problem with logarithmic functions is that most of the calculators won't graph them. Even graphing calculators won't graph it. So what we have to do is, instead of graphing the logarithmic function, we have to graph the inverse. We have to take your logarithmic equation, invert it, and then graph the inverted exponential function. So here we have log base 2 of x. We're going to get the inverse of that, which is 2 to the x, and we're going to graph that in our calculator. All right? So you type 2 to the x into your calculator, and you get this lovely table of values, right? And what you do with this to graph your logarithmic function is two things. Two different ways you can do it. One thing you could do is you could plot these points. Right? That's going to give you the exponential function, and then you can plot the inverse. All right? Or you could just take the table and switch your x's and y's, and this gives you the graph of your the logarithmic function. Because you really don't care about the blue exponential function. We just want the logarithmic function. So we just want this table. All right? And that's how you're going to have to do it. You're going to have to get the inverse of the function, graph the exponential function, get your table of values, right? Flip your x's and y's, and then plot those. And it's annoying, but that's the way it has to be. All right. Now, looking at this red logarithmic function, we see that the domain is all x's such that x is greater than 0, because we just want stuff to the right of the y-axis. But the range is all real numbers, because it's going to go down to positive and negative infinity. It's going to go up to positive infinity. All right. Now, let's take a look at this. That's how to graph the functions. Here's how to transform the functions. And you see, we still have that same a, b, h, and k that we've had for every function we have ever dealt with. Linear, absolute value, quadratic, cubic, cube root, quartic, doesn't matter. Exponential functions all have the same a, b, h, and k, and they do the exact same thing. It's just that logarithmic functions is going to look a little bit different. Same numbers, just in a slightly different presentation, if you will. All right. So here we have log a times the log of base, whatever a base is, of b to the bx minus h plus k. All right. So we have the same thing. It's just instead of having a square out here, we have a log in front of it, logarithm. All right. This base, that's just whatever the base is. And if you look here in this table, this looks just like every table we've ever had on transformations. You'll see the only difference is here we have common log, here we have log base 2, here we have natural log, so base e. Right? And you'll notice it really doesn't matter what the base is. The transformations are exactly the same all the way down. H is still a transformation left and right. It's a slide. And it goes opposite the direction that it looks like it should go. If it's negative, it goes to the right. If it's positive, it goes to the left. All right. K is still a vertical translation. It's going to slide it up, or it's going to slide it down. Up if it's positive, down if it's negative. The reflections still look the same way. It's still a negative. If you have a negative x, so if b is negative, it's a reflection over the y-axis because that's a horizontal move and everything in the parentheses is horizontal. If it's a negative out in front, so if we have negative a or negative log, negative natural log, whatever, then this is a reflection over the y-axis. It's on the outside, so that's a vertical move flipping over the y-axis. All right. B is still a horizontal stretch or shrink. And again, it shrinks if it's less than 1. It stretches if it's greater than 1, right? Because it's backwards. And A out in the front, this is a vertical stretch or shrink. Stretch if it's greater than 1, shrink if it's less than 1, and a reflection over the x-axis if it is negative, which we saw right there. All right, so that's all the same stuff we've had before. So here we go. We're going to take some functions. We're going to come up with the transformations, and we're going to graph them. You're definitely going to want to find the transformations first because the transformations are hard to see in the logarithmic functions. So we're going to take a look at our f of x is common log of x. G of x is common log of negative 1/2 x. Find anything that's different between f and g. That's what your transformations are going to be. So in this case, what we have is this negative 1/2. So that's where our transformations are coming from. So looking at this, we see it's in this format, and let's use A here, which I don't like. It should be B, but whatever. Use what we got. And so our B value is negative 1/2. So that's on the inside. So this is a flip because it's negative. It's flip over the y-axis because it's horizontal because it's on the inside. And the 1/2, stretch or shrink. Less than 1, so you think it's a shrink, but nope, it's a stretch because horizontal is backwards. So this is a stretch by a factor of 2. And if you look at the graph, you're definitely going to want to get the transformations from the function, not from the graph. Because the graph, you can see that it flipped over the y-axis. You can't very well see the stretch by a factor of 2. So you definitely get your transformations from the equation, not from the graph. B, well, what's different between f of x and g of x? Well, the difference is we have a 2 out here and we have a plus 4 on the inside. Well, 2, it's on the outside, so this is going to be vertical. It's multiplication, so it's a stretch or shrink. Greater than 1, so it's a stretch. 4, that's on the inside, so this is the h position because it's addition. And remember, it's backwards, so h is negative 4 because it's x minus h. And so we are moving to the left. Right? So this moves our graph 4 to the left, vertical stretch by a factor of 2. Easy to see the vertical translation because it moves that asymptote over. Hard to see the vertical stretch. So again, you're going to want to get your transformations off the function, not off the graph, because the graph is kind of hard to see what happened other than the slides. Slides you can see, reflections you can see, stretches and shrinks, not so much visual there. Definitely want to get those off the functions. So what I want you to do, find the transformations on 5 and 6, pause the video, work it out, then come back and check your answers. Alright, let's see how we did. Number 5, difference between f and g, we have this -3 in the front, and that's it. So it's a negative, it's a 3, they're both out, not here with the x, so these are vertical, negatives are flip, 3 is a stretch. So we have a vertical stretch by a factor of 3 and a reflection over the x-axis. Alright. Number 6, what's different between f of x and g of x? Well, there's a 4 in here with the x, and there's a -5 on the outside. 4 is in with the x, so this is a horizontal move. It's multiplication, so this is a stretch or shrink. Since it's greater than 1, and it's horizontal, it's backwards. This is a shrink by 1/4. The -5, it's on the outside of the parentheses there, so this is your k position. It's just going to slide it down 5 units. That's all you got. Next, we're going to take this the other way around. Now they're going to tell us the transformations, and we have to come up with the equation. Alright. So we have f of x is log base 1/3 of x. We want g of x to be a translation 2 units up, followed by a vertical stretch by a factor of 2. Anytime you have this followed by, you want to do your equation in 2 steps. Alright. First, we're going to take care of this translation 2 units up. Alright. So 2 units up, this is a slide. This is going to be in the k position. Alright. So we're going to do this in 2 steps. We'll start with h of x is just an intermediary here. And so f of x plus 2, because it's in the k position, sliding it up. So we're just going to take log base 1/3 of x and add 2 to it. There it is. Not too bad. Next, we're going to take care of this vertical stretch by a factor of 2. Well, let's see, vertical, so that's going to be on the outside of this. So it's going to apply to the entire thing. Stretch, this puts this in the A position, and so we're just going to multiply everything by 2. So it's 2 times this h of x stuff that we got right here. All right. So remember, with this vertical stretch, it's times the entire thing, not just times the original. We've added 2 to it because that came first. So this slide up 2 has to be taken into account. So this vertical stretch applies to the whole thing. Distribute that in, and we end up with 2 log base 1/3 of x plus 4. All right. And so our transformed function is this right here. And in the graph, you can see it if you take it step by step. So you start with f of x. Slide it up 2 puts you to g of x, and then you take the whole thing and you stretch it by a factor of 2. So everything gets, the y values get doubled. So when it comes down here, it gets doubled down, going down. All right. So I want you to do one on your own. Okay, I want you to pause the video, work out the rule for g, then come back and check your work. All right, let's see how you did. First, we have, here's our base, common log of x. This is base 10. All right, we have a reflection in the y-axis, followed by a translation 4 units to the left. Well, a reflection in the y-axis, that is a horizontal move, remember, because we're going this way over the y-axis. And then what we're going to, so that's horizontal, so it's on the inside just to the x. It's a reflection, so it's negative. So we're going to have negative x, and 4 units to the left is going to be minus 4. Actually, we have 4 units to the left. It's plus 4, but that negative does get distributed to the 4 as well. And so it gets a minus 4. And it's really weird, but there it is. We don't really like horizontal translations, I'll admit. They're not my favorite. So that negative here, it applies to the whole thing. It applies to this minus 4 as well. And so the plus 4 becomes a minus 4. So, all right. that is transformations of logarithmic functions and logarithmic graphs. I hope you found this useful, and I'll see you next time.